Today, we are going to discuss common problems involving exponential functions. To define, an exponential function is a function of the form f of x is equal to a multiplied by b raised to x, where a and b are real numbers and b is positive. These exponential functions are often used to model relationships with exponential growth or decay, and also in determining the value of a certain amount of money after years in a compound interest. But today, we will focus on the application of exponential functions in real-life situations. You see, exponential functions are not rare as you think it is. It is usually applied during investments to determine annual interest or just simply determine the hypothesized results in science. Basically, it's everywhere. So to start, let's break down example situations in three: exponential growth, exponential decay, and compound interest. First is exponential growth. Exponential growth occurs when a function's rate of change is proportional to the function's current value. For example, a biologist observes through a microscope the growth of a bacteria on a petri dish. She observed that the bacteria doubles every 96 hours. If there were initially 10 bacteria, how many would they be after 5 days? The first step is that we should convert 96 hours into days, since it's easier to be converted instead of 5 days. 1 day is equal to 24 hours. So 96 hours divided by 24 hours is equal to 4, and this is the number of our days. This is necessary for us to substitute the given to the formula in a manner which works immediately. Then will be substituted to y sub 0 since it is the initial amount. The formula for this problem would be y is equal to 10 multiplied by 2 raised to 5 days over 4 days, which would be equal to 23.7841423. After computing the function, we will know that after 5 days, there shall be 24 bacteria on the petri dish.
Second is exponential decay. Exponential decay is used to model radioactive decay or half-life. Half-life is the time it takes for half of a substance to decay. Exponential decay is simply when a quantity halves itself every t units of time. Another problem. Iodine 131 is a very radioactive isotope, which has a half-life of 8.07 days, where a typical year corresponds only to 365 days. If there are 300 grams of iodine 131 initially, determine the mass left after 2 years. First, we shall convert 2 years into days first, and that shall be equal to 730 days. After this, we can substitute all given units to the formula for exponential decay and compute, where 300 grams is the initial amount, so the formula will be y is equals to 300 times 1 half raised to 730 over 8.07 days. And after computing, we can see that y is equals to 1.76 times 10 raised to negative 25 grams. And that will be the mass of iodine 131 after 2 years. Last is compound interest. In compound interest, we have two things to remember: principal and compound. These terms will help us determine the type of problem and formulas to be used. A starting amount of money, called the principal, can be invested at a certain interest rate that is earned at the end of a given period of time, such as 1 year. If the interest rate is compounded, the interest earned at the end of the period is added to the principal, and this new amount will earn interest in the next period. The same process is repeated for each succeeding period. Interest previously earned will also earn interest in the next period. A compound interest may be represented through the function below. If our principal P is invented at an annual rate of R, compounded annually, then the amount after 3 years is given by A is equals to P times the quantity of 1 plus R raised to T. For example, if 5,000 pesos is placed in an account at a 5% interest rate and is compounded quarterly for 5 years, How much is in the account at the end of 5 years? Compounded n times a year, and after 3 years, the total amount is given by A is equals to P times the quantity of 1 plus R over N raised to NT. Since it was mentioned that the money is compounded quarterly, N will be equal to 4. 5,000 is the principal, while R is equal to 0.05, where 5% was divided to 100. Hence, A is equals to P times the quantity of 1 plus R over 4 raised to 40, which is equals to 5,000 times the quantity 1 plus 0.05 over 4 raised to 20, and the result will be 6,410.19 pesos. So after 5 years, we can say that the account shall have that value.